Hi there. In this video, we'll be talking about temperature scales, what they are, how they compare to each other, and how we can convert a temperature that's in one scale into a temperature that's in another scale. So depending on where we live, we might be used to one or more of these scales already, but most students in chemistry classes haven't yet seen all three. So the scales that we'll discuss first is the Fahrenheit scale, which is abbreviated with a capital F. The Fahrenheit scale is the typical scale in the United States and a few other places around the world in which sort of our weather, outdoor temperature, indoor temperature, those sorts of things, how they're reported. The Celsius scale is the scale that's used most widely around the world for those same sorts of measurements. And then in the sciences, the standard scale for which to measure and report temperature is the Kelvin scale. They have some slight differences between the three of them, and so I've just kind of marked that here. So one of the really common ways to think about all three of these scales is to think about where water freezes and where water boils. So if you're used to the Celsius scale, you probably know that water freezes at 0 degrees Celsius. Okay? A unit on the Celsius scale is called a degree, but a unit on the Fahrenheit scale is also called a degree. So whenever we talk about temperatures in the Celsius scale or the Fahrenheit scale, we need to give both the name of the unit, the degree, and then the scale in which we're using. So degrees Celsius or degrees Fahrenheit. So on the Celsius scale, we know that water freezes at 0 degrees Celsius, and we know that water boils at 100 degrees Celsius. So there are 100 divisions between the point at which water freezes and the point at which water boils. If we look at the Fahrenheit scale instead, we see that rather than freezing at 0 degrees on that scale, water freezes at 32 degrees Fahrenheit. Okay. And we see that water boils at 212 degrees Fahrenheit. So if you look at that difference, there are 180 divisions between the point at which water freezes and the point at which water boils. Okay. That's one of the maybe the little benefits of the Fahrenheit scale is that the divisions, okay, the size between each degree is smaller in the Fahrenheit scale than it is in the Celsius scale. 180 degrees Fahrenheit between freezing and boiling. Only 100 degrees Celsius between freezing and boiling on the Celsius scale. Okay. So if we want to know how to convert between those units, we need to have this sort of information in our mind, where the scales are relative to each other, so let's say the point that water freezes, and then how big the divisions are between freezing and boiling. Right? If we look at the Kelvin scale is slightly different. The Kelvin scale was developed to describe something that's called absolute zero, the point at which there is no heat in an object. Remember, that's kind of what temperature is. It's a way to describe how much heat is in matter, or a way to describe our interaction with something that might have heat. If something feels cold to us, meaning it feels like it doesn't have much heat, then we call that object cold, and we would say that it has a low temperature, right? So the Kelvin scale describes what's called absolute zero, where there is no heat in an object. Okay? And so if we know that point, if we're going to call that point 0, then we can also say something about where it is that water freezes on the Kelvin scale. So it turns out that water freezes at 273.15 Kelvin. Okay? Just a side note here, you notice that I didn't say degree Kelvin. All right, so in the Celsius scale and the Fahrenheit scale, the name of the unit is a degree. So we have to say the unit, degree, and then the scale that we're using. On the Kelvin scale, the name of the unit is Kelvin. So we can just say the number and the unit. So 273.15 Kelvin. Right? So water freezes at 273.15 Kelvin. It boils at 373.15 Kelvin. Okay, so you notice here that on the Kelvin scale, just like the Celsius scale, the difference between freezing and boiling, it's 100 divisions. Okay, so the size of a Celsius degree and the size of the Kelvin unit are in fact the same, right? So there's 100 degrees between 100 degrees Celsius or 100 Kelvin between freezing and boiling, right? Well, 0 on the Celsius scale was chosen to describe water freezing. 0 on the Kelvin scale was used to describe no heat, right? So if we think about, well, what is no heat in the Celsius scale? Well, it would be minus 273.15 degrees Celsius. We can also think about what would that 0 be? What would no heat in the Fahrenheit scale be? It turns out to be negative 459.67 degrees Fahrenheit. Okay. So these are the three scales, and with this knowledge, we can come up with some relationships to allow us to convert between one unit system and another unit system. Okay. So one of the things we said here is that for Kelvin and Celsius, the size of the unit is the same in both scales. Those two scales are just offset from each other. Okay? And so if we think about what's the relationship between Kelvin and Celsius, we see that the units Kelvin are equal to the degrees Celsius plus 273.15, right? So 0 on the Celsius scale, 0 degrees Celsius plus 273.15 gives us that temperature on the Kelvin scale. If we think about water boiling at 100, add 100 to 273.15, what do we get? 373.15. Okay? And of course we can go backwards with this particular temperature scale. Here we're starting with degrees Celsius and calculating the number of Kelvin. What if we wanted to go backwards? Well, we would just flip this equation around and say that the degrees Celsius is equal to Kelvin minus 273.15, right? So using the opposite of this equation can get us to convert from Kelvin to degrees Celsius. Okay? The conversion between Celsius and Fahrenheit is a little more complicated. These two scales are offset from each other as well, right? 0 Celsius is 32 Fahrenheit. So the scales are offset, so there's going to be some addition or subtraction. But remember, where there's 100 divisions between freezing and boiling here, there's 180 divisions between freezing and boiling here. So we have to take into account that the scales are offset and that the scales are different sizes. Okay? And so the equation that we get is right here. We know that if we start with degrees Celsius, if we take that number and we multiply it by 9 and then divide it by 5, okay? So multiply this number by 9/5, and then add 32, we'll get the degrees in Fahrenheit, right? And so if we start with 100 here, okay? If we start with the degrees Celsius for boiling water, if we take 9 and divide it by 5, that's equal to 1.8, okay? So 1.8 times 100 is 180. 180 plus 32 is 212 degrees Fahrenheit, right? So 100 degrees Celsius is 212 degrees Fahrenheit, right? Just like we did here, let's reverse this equation as well so that, in case instead of converting from degrees Celsius to degrees Fahrenheit, what if we want to go the other way? Well, let's just reverse that equation. And so the way that we're going to do that, the first thing that we'll have to do is subtract 32 from both sides. So we'll say degrees Fahrenheit minus 32, okay? That's going to be equal to 9/5 degrees Celsius. And so if I want to get rid of that 9/5 so that I'm just left with degrees Celsius, I'm going to end up dividing both sides by 9/5, right? Which is the same thing as multiplying by 5/9. So I'm going to take degrees Fahrenheit minus 32 times 5/9, and that's going to equal degrees Celsius, okay? And so we could work that out real quick, right? So let's go back to this example here. So let's say we're starting with 212. 212 minus 32 is 180. And then we have to take 180 and divide it and multiply it by 5/9. So 180 divided by 9, we can do that in our head. That's 20. And then 20 times 5 is 100. Okay? And so now we've got all of the equations that we need to be able to convert between some unit systems here. All right? And so let's do a couple examples. What if you were asked to convert from, say, 37 degrees Celsius, and you're asked, what is that temperature in degrees Fahrenheit? Okay? And this is a pretty good example here because 37 degrees Celsius is what's considered body temp. So in your head already, you might know the answer in degrees Fahrenheit, but let's calculate that out. Okay, so how are we going to do this? Well, we're starting with degrees Celsius and we're converting to degrees Fahrenheit. So we want to use this equation here, right? So we want to say, okay, well, degrees Fahrenheit is going to be equal to 9/5 times 37 plus 32. Okay, so what is that going to be equal to? Well, can't quite do that one in my head. So let's pull up our calculator. And so we'll say 9 divided by 5, right? We said that was 1.8. 1.8 times 37 is equal to 66.6 plus 32. And that equals 98.6. So 98.6 degrees Fahrenheit is what we call average body temperature, right? Okay, let's try another one. What if we wanted to convert this 37 degrees Celsius? What if we wanted to know, well, what's average body temperature in Kelvin, right? So we're starting with 37 degrees Celsius, and we want to know how many Kelvin is that, okay? And so in order to do that, we're starting with degrees Celsius. We want to go to units of Kelvin. And so we're going to use this equation here, right? And so the way to do that is to just say, well, let's take this degrees Celsius and add 273.15 to it, okay? So our Kelvin is going to be equal to 37 degrees Celsius plus 273.15, right? Okay, and again, I can't quite do, well, that looks like it's going to be, 310.15 Kelvin, right? So 37 plus 273.15, that's going to equal 310.15 Kelvin. Okay, so 310, 37, and 98.6 are all the same number, or all the same measurement, provided that we include the units. So 310 Kelvin, 37 degrees Celsius, and 98.6 degrees Fahrenheit. Okay, let me erase the board here. We'll try one more. Okay, I've erased the board and put up a new problem here. So our problem is, how many Kelvin are equivalent to 72 degrees Fahrenheit? 72 degrees Fahrenheit, of course, is what's considered sort of room temperature, okay, kind of a comfortable temperature that we would keep our room at. And so in this question, we're being asked to convert from degrees Fahrenheit to Kelvin, okay? That's not a conversion that we have up here on the board, and so we can get there. It's just going to take more than one step, right? So we want to be able to go from, say, degrees, we want to be able to go from degrees Fahrenheit to Kelvin. We can't do that directly, but what we can do is go from degrees Fahrenheit to degrees Celsius, and then from degrees Celsius to Kelvin, right? So we can go from degrees Fahrenheit to Celsius, check, okay, and we can go from Celsius to Kelvin, right? So there's the two formulas that we're going to want to use here. So let's go ahead and do that math. So our first step is to go from degrees Fahrenheit to degrees Celsius. Okay, so we can say how many degrees Fahrenheit are equal to, oops, I'm sorry, 72 degrees Fahrenheit is equal to how many degrees Celsius, right? And so what I can say here is, well, let's say 72 minus 32 times 5/9, that's going to equal some number of degrees Celsius, okay? So let's do that math, right? So we've got 72 minus 32, that of course equals 40, times 5, it's 200, divided by 9, and that's 22.2 repeating, okay? So that's going to equal 22.2 repeating degrees Celsius, all right? So, and that sounds about right. Around 72, room temperature in Celsius is around 20 degrees Celsius, so 22.2. All right, so now let's do the second step here, where we're going to take this number in degrees Celsius and convert it to Kelvin, right? And so now what we're going to want to say is that, okay, our amount in Kelvin, our temperature in Kelvin, is going to be equal to 22.2 repeating plus 273.15, right? And so in our calculator, I'll just save our number from before and just add to it 273.15, and that equals 295.372 repeating. Let's call that 295.4. Okay, 295.4 Kelvin. So how many Kelvin are there in 72 degrees Fahrenheit? 295.4. All right. Well, I hope this video was helpful, and I'll see you next time.